Okay, pre-cal students, in this video we will be looking at multiplying and dividing complex numbers in trig form. We will also be looking at taking roots and powers of complex numbers in trig form. Okay, so copy down this heading if you would please. This heading is huge. Okay, so I'll pause a minute or so while you work on copying this heading down. My pen is not working. Hold on one second. I guess it helps if I turn the mimeopad on. Okay, there we go. I turned it on. Yep, makes all the difference in the world. Okay, go ahead and copy this heading down if you would, please. Multiplying, dividing, powers and roots of complex numbers. Okay, copy this heading down. I will wait about 20 minutes. Just kidding. While you copy this heading down, notice we are in lesson 13.5, and be sure and include today's date. Okay, we're going to multiply, divide, take the powers and roots of complex numbers in trig form today. Lesson 13.5, and be sure and include today's date if you would please. Okay. All right, you can continue to copy this down even though I switched pages, so here we go. Let's start off by looking at multiplying complex numbers in trig form. Okay, so the first thing we're going to do is multiply complex numbers in trig form. Now, first I want to show you why this is so helpful, so please do not take notes on this, just watch. Okay, if I had 3 minus 2i times 6 plus, I don't know, 5i, and I asked you to multiply those two complex numbers together, you would have to take the 3 and multiply it through. So you would get 18 plus 15i. Then you'd have to take the 2i and multiply it through, and you would get minus 12i minus 10i squared. Okay? Now next, you would have to take your I squared, and where the I squared is, don't forget that I squared is the same thing as -1, so you'd have to put a -1 there for the I squared. So now you would have this 18 plus 15i minus 12i, and then a negative times a negative would be a positive 10. And then lastly, you would have this for your answer, 28 plus 3i. Okay? Now that's a lot of, not a lot of work, but it's plenty of work. Okay? And so when you're multiplying complex numbers that are written in standard form, there's a little bit of work involved. Okay? However, when you multiply complex numbers that are in trig form, it is so much quicker and so much easier. Okay, so here is how it is done. Please take some really good notes on this. I'm only going to give you one example because it's so easy to do. In fact, I'm only giving you one example of this, one example of this, one example of this, and one example of this, because the math today is not difficult. It's just something that you need to learn how to do and then practice it over and over in your homework. Okay, so here's the problem we're going to look at first. Let's multiply these two complex numbers together. Put a little dot right here, I guess. There we go. Okay, now watch how easy this is. It is so simple. Notice how our complex number here is written in trig form, and notice how this complex number is written in trig form. That's so easy. Now, what you do when you multiply these together is you take the hypotenuse here and you multiply it together. That's easy. Wow. Piece of cake. And then you add the angles. So you have cosine of 375 degrees plus I sine of 375 degrees, and you're finished. That's simple. Now, it is true that sometimes I will ask you to write this final answer in complex or in standard form. Well, that's still easy to do, students. I mean, all that you have to do is you realize 375 degrees is wrapped around 360 plus 15 more, so you have 15 degrees here. you have 2 square root of 2, and you can so very quickly find your x and your y so very, very quickly. Okay, I'm not going to do that for you, but here's the main thing I want you to see. When you're multiplying two complex numbers that are in trig form like this, all that you do is take the hypotenuses, if there is such a word, and you multiply them together. And then you take the angles and you add them together, and you're finished. It's that easy, okay, guys? Wow, that's a lot faster than what we did before up here with all of this here. That's a lot faster, okay? Okay, moving on to our next part today. Let's move on to dividing complex numbers that are in trig form, okay? Dividing complex numbers that are in trig form. So here we go. First of all, I want to show you why this is so helpful. So you do not need to take notes on this, although if you want to, you can, but you don't have to. If I had 2 minus 2i divided by 3 plus 4i, I'm just making this up, okay? Now, what you'd have to do is this. You would have to multiply the top and the bottom by the conjugate of this. And the conjugate of this would be 3 minus 4i. That's a lot of work, okay? First of all, you're going to get this for the numerator. It's 2 times all of this, 2i times all of this. You're going to get, let's see, 6. And then you'd have positive 8i squared. And in the middle here, you'd have negative 6, negative 8, so negative 14i. Then you'd have to put a negative 1 in for this, make it a negative 8. So you'd finally end up with negative 2 minus 14i. And who knows? I did that quickly. I might have made a mistake somewhere. Who knows? I very well could have. Now here in the denominator, you would have 9 minus 12i plus 12i. So they cancel out. And then minus 16i squared, which makes that a positive 16 because it's a negative 1, 25. So you end up with negative 2 25ths minus 14 25ths I. Okay? Now, that's fine, but that's a really long method, okay? So, watch how easy it is to divide complex numbers that are in trig form. It's really simple to do. Here's how it's done. Watch this carefully. Notice once again I'm dividing complex numbers. However, they're written in trig form, not standard form. Remember, standard form is this. Okay, that's standard form. Now watch this. You take your two hypotenuses, again if there's such a word, and you divide them. 2 divided by 4 is 1/2. Well, that's easy. Then you subtract your angles. And it is important that you subtract them in the right order. It's the top angle minus the bottom angle. So 270 minus 90 would be 180 plus I sine of 180. Subtract your two angles here. That's it. Now that is so much faster than this over here. Now again, there's nothing wrong with this method if a complex number is given to you in standard form. But isn't it cool how I can take this problem here like this, and it becomes so much easier when it's written in a different form. Now you're seeing how helpful it is to have complex numbers written in trig form, because all they're based on is the direction angle and the length of the hypotenuse, and that's it. So it's really, really helpful, okay, to have a trig form of a complex number. Okay, moving on. Hopefully this makes sense. Let's review one more time. You take your two hypotenuses, you divide them, and then you subtract your angles. Take your top angle minus your bottom angle. Okay, pretty simple. Okay, moving on. Now, we are going to look at raising a complex number to a power. Okay, and like I've done the whole time, doing this with standard complex numbers is very, very long and tedious. Let me show you. Now, if you want to take notes on this, you're welcome to, but you don't have to. It's totally your decision. So here we go. Let's say I'm taking 3 minus I, which is a complex number in standard form, and let's say I'm raising it to the 4th power. Okay, so here we go. Well, first of all, I have to write my parentheses 4 times. Okay, then I would probably multiply these two together and put them in a parentheses, and multiply these two together and put them in a parentheses, okay? So if I did that, here's what I would get, okay? I've already done all the work for you and simplified it. Now, I've got to take this trinomial here times this trinomial here. So this 9 here gets multiplied all the way through. This -6 gets multiplied all the way through. This positive I squared gets multiplied all the way through. I think you get the idea. This is going to be really long. And you come up with this here, okay, which is really bad. Now, everywhere that you see an I squared, you're going to put a -1. And also, if you see an I cubed, you're going to rewrite that as I squared I, which is the same thing as I cubed, and then put a -1 in for I squared. That's a lot of work. So you would end up with this here, okay? Then if you combine all your like terms, you'll come up with this. So finally, there's your answer, okay? Now watch how easy it is to take a complex number written in trig form and raise it to a power. It's so much easier. Watch this. Take some really good notes, okay? Okay, we're going to take this complex number right here, which is written in trig form, and we're going to raise it to the 9th power. So we're going to raise this to the 9th power, okay? Now here's how easy this is. Whatever your hypotenuse is right here, you're going to raise that to the 9th power. So I have square root of 2 to the 9th power. Your calculator will do that for you if you wanted to. And then you simply take each angle and you multiply it by 9, and you're done, okay? So here, let me grab my calculator real quick. 45 times 9 would be 405. So we have cosine of 405 degrees plus I sine 405 degrees. And now square root of 2 to the 9th power. Well, guys, let's do that real quick, okay? Square root of 2 written 9 times. Now remember, every time you multiply square root of 2 times square root of 2, you get 2. So multiply these together, you get 2. Multiply these two together, you get 2. Multiply these two together, you get 2. Multiply these two together, you get 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 square root of 2. So you would really have right here 16 square root of 2. And by the way, on a test or a quiz, I would want you to simplify it down to this right here. And there's your answer. That is so much easier than this over here. So much easier. And you're going to become pretty fast at these because we're going to practice these, and they're really simple to do. Okay? So far we have learned, well, we'll go back and review in the end, okay? Let's take a look at one more type of problem. And I know the video is pretty short today, but I want you to focus most of your time today on your homework more than notes, okay? Lastly, let's look at taking roots of complex numbers in trig form, okay? Now, here is what it would look like if I attempted to take the roots of a complex number in standard form. For example, let's take the cubed root of 5 plus 2i. Well, there's nothing you can do. You're finished, okay? Now, I'm not saying there's not an answer. It would just basically be impossible to find with your answer written in this form here. It's just difficult to do. So, watch this carefully. What if I said to you, let's find the, let me look at my notes here. Let's find the, hold on just 1 second, students. I apologize. Let's find the 3 cubed roots. Okay, let's find the, write that down please. Let's find the 3 cubed roots of this complex number. Or in other words, the cube root of this. Now, that's basically impossible to do when it's written in standard form. So, I'm not going to take time and do this for you because we've learned how to do this the other day, but if I took this and wrote it in trig form, you would get this right here. Go ahead and take notes on this, guys. Square root of 8 cosine 135 degrees plus I sine of 135 degrees. There we go. So I rewrote this into this. Now all I have to do is teach you how to find the cubed roots of this, and we'll be done. But it's a little more difficult than the other three, so please take some really good notes, okay? Here we go. Take some really good notes. Okay, first of all, let's start off by doing this. The first thing you do is you take the cubed root. Since we're trying to find cubed roots, you take the cubed root of your hypotenuse, okay? So here's what we have. We have the, I'm going to do a bunch of work down here, so take some really good notes, students. Here we go. I have the square root of 8, and I'm taking the cubed root of that. Okay, now watch. Hopefully you remember this from Algebra 2, okay? Now the square root of 8, remember, square root means there's a 2 there. And what's the power of the 8? 1. So really we have this. Hopefully you remember this from Algebra 2. 8 to the 1/2 power. Okay, the 1 right here goes in the top part of the fraction, and the index, the 2, goes in the bottom. So now I have 8 to the 1/2 to the 3rd power. Okay, or to the 3rd root, excuse me. Now let's go ahead and take this a step further. Really what that means is this. Let's think about this. That means I have 8 1/2. Now what does cubed root mean? 1/3 power. So I have 8 to the 1/2 power raised to the 1/3 power, which would be 1/2 times 1/3 is 1/6. So if I take the cubed root of this, I end up with the 6th root of 8, or 8 to the 1/6 power. Let's look at this again, okay? I have the square root of 8, which is 8 to the 1/2. And then I then take the cubed root of 8 to the 1/2, and of course the cubed root is 1/3, so I have 8 to the 1/2 to the 1/3 power. And 1/2 times 1/3 is 1/6. Now 8 to the 1/6 power is the cubed root of 6. So the cubed root of the square root is the 6th root of 8. Alright? Now, here's what you do next. Whatever this number here is, right here, now watch this carefully. You take your angles here, you divide by 3. Now the reason you divide by 3 is because you're dealing with the cubed roots. If this would have said a 4th root, then you would divide by 4. If this would have said a square root, then you would divide by 2. Okay? So, we have, let's see, 45 degrees, 135 divided by 3, plus I sine of 45 degrees. Now, here's the thing. Let's review. We take our hypotenuse and we take the cubed root of the hypotenuse. If it was a square root, then we would take the square root of the hypotenuse. Next, we take the angle here and we divide it by 3. Now that we've done that, it looks like we're finished. The only problem is this, and please don't forget this, students. If we are finding the square root of a complex number, then we want 2 answers. If it's a cubed root, then we want 3 answers. If it's a 4th root, then we want 4 answers. Okay? So because we're trying to find the cubed root of this complex number right here, then we want 3 answers. Okay? That's how it's always going to be. So here's what you do. It's so simple. This does not change for your other 2 answers. Okay? And 360 does not change. You always take 360 and divide it by whatever the root is. So in this case, it's 3. Now again, if we were taking the 4th root, then we would divide by 4. If we were taking the square root of this number, then we would divide by 2. We divide by 3 and we get 120 degrees. So you simply add 120 degrees over and over to these angles until you have all the answers that you need. So here's this answer. 120 plus 45 is 165. There's one answer. Here's the next answer. We're going to add 120 again, so we'll get 285. And now lastly, students, most of the time in these problems, they're going to want your final answers to be written in complex standard form. So we have learned how to do that in the past. I'm not going to do it for you now, but I will give you the answer. This would end up being 1 plus I. This would end up being here, negative 1.366 plus 0.366I. And this answer here would end up being 0.366 minus 1.366I. Now here's your answer. So I asked you to find the 3 cubed roots, and you did that right here. Okay? So you might have to back this up and listen to it again if you're a little confused. A little complex, but not too bad. Now here's what I'm trying to show you. Here's what's so cool. Watch this. This is pretty neat. Watch this carefully. So Mr. Earhart, are you telling us that if I took, let me show you, let me back up and say this. Remember, if I asked you to find the cube root of 8, you would say the answer is what? 2. Because you know what? 2 times 2 times 2 is what? 8. So Mr. Earhart, are you telling us that if we take 1 plus I and raise it to the 3rd power, we'll get this here? Yes, I am. And if I take this right here and raise it to the 3rd power, I'll get this? Yes, you will. And if I take this right here and raise it to the 3rd power, will I get this? Yes, you will. So here's the thing. We started off like this. The cubed root of what? Negative 2 plus 2I. Right here. What could have you done with that, students? Absolutely nothing. There is nothing you can do to this except say you're done and circle it. But since we wrote it in trig form and then learned how to find the 3 cubed roots of a complex number written in trig form, now we come up with 3 answers that are truly the cubed roots of this complex number here. So pretty cool, okay? All right, let's quickly review. Let me get a little drink here. Let me scroll up. I'm drinking some good old coffee here. Let's see here. Okay, first of all, when you're multiplying numbers that are in complex numbers in trig form, you multiply the hypotenuses and you add the angles. When you're dividing complex numbers in trig form, you divide the hypotenuses, if there is such a word, and you subtract these angles here. Make sure you take the top angle minus the bottom angle, okay? And moving on, when you are raising a complex number in trig form to a power, you take this here and you raise it to this power, so square root of 2 to the 9th power, and you take these angles here and multiply it by this number here. Okay, pretty simple. And then lastly, when you're taking complex numbers in trig form, which I erased already, sorry about that, and you are taking a root of them, whatever the hypotenuse is, you take the root of the hypotenuse, and then whatever the angles are, you take the angle and you divide it by whatever root you're taking. The cubed root, divide by 3, 4th root, divide by 4. And then don't forget that you'll have, if it's a cubed root, you'll have 3 answers. If it's a square root, you'll have 2 answers. If it's a 6th root, you'll have 6 answers. Okay? So that's basically it. Hopefully this will be a help to you as you work on your homework. Call or email if you have any questions.